Now I'd like to turn to our next speaker. It's Dr. Eric Nettleton. Eric is an experienced innovation and technology professional who has held strategic leadership roles in multiple industries, including mining and aerospace, IT and academia. He's head of automation at Newcrest, and Newcrest is one of our partners in DARE, so we're thrilled to have Eric speak today. He has interests in information fusion, robotics, and whole of business technology and automation platforms. So without further ado, Eric, I'd like to invite you to speak.
Good afternoon. Thank you. I'd just like to start by thanking Sally and the DARE team for the invitation to talk today about uncertainty in mining. As per the intro, my current role is head of automation at Newcrest Mining. Start by saying mining is a complex business that operates with a wide variety of uncertainty conditions, I guess like all businesses. But for the purposes of this talk, I guess I'll focus primarily on the idea of uncertainty in data or in information and what it can be used for. A particular focus of this, given my own role, and to give I guess some context as well, is how it's relevant and evolving with the introduction of automation technologies. This includes a bit of commentary around the types of data we're generating in typical mining operations, how it's typically represented in some of the use cases. I'd also like to explore some of the open research areas in this space that might be relevant to this audience. Right at the outset, let me say what I won't do is show any equations. I thought about showing some pictures, but even that will probably pass over Zoom. But right now, it's a really exciting time in automation in mining. If you've read anything in the media over the last few years, you'll see that there's now automated drills, trucks, loaders, underground equipment. It's all starting to get to the point where the adoption is getting traction in the industry. I've worked in a range of different fields in automation, as I said before, but over 20 years ago now, I was writing localization systems to automate underground load haul dump vehicles, underground vehicles. They worked. They went from A to B, but they never really stuck in the industry yet. It's taken a long time to get to the point where these technologies are mature enough that they're starting to get consumed. Soak on that for a second though. 20 years, it's a couple of decades. That's not abnormal for how long it takes to get some new technologies, new algorithms into an industry at scale. So I didn't really want to talk too much about what's off the shelf. I guess a lot of people here will be familiar with existing state of technology. I want to talk through some of the directions the technology, data analytics and automation seem to be taking and what that can mean for us. There's an abundance of buzzwords in the space. There's things like IoT, big data, analytics, industry 4.0, mining 4.0, AI. What do they all mean? I mean, at the end of the day, there's countless PowerPoints and papers floating around. But if it was as simple as I was led to believe by those, we'd be buying it off the shelf, and we're not. So one of the biggest benefits in mining, or I guess any business, would be to really understand what you're doing in real time so you can control your business better. For mining, we talk about integration along the value chain, about one version of the truth in our data. But how do we combine all of the information? How do we take the technical excellence that's in place in many areas of the business and actually end up with an integrated solution? And even if we can technically do it, think back to that 20-year comment, how do we evolve within the industry to make any change commercially viable and at scale? So I guess take a lot of this as a thought starter on where we can get to and some thoughts on how. I guess I'm happy to follow up with anyone on these and Q&A or one day when COVID passes in person. So let me go back to the basics again. Mining processes and systems have been operating for a very long time. They work. We successfully mine commodities today. And we definitely do it generating a large amount of data. And the more systems we deploy, the more data we generate. It's used for a wide variety of tasks at time horizons from immediate real-time systems through to life of mine style systems. We track vehicle location to control and optimize material movements. We measure geological information to understand the ore bodies, and we use that to drive core business. The data is used all the way through the mining process, both for people and equipment. It's critical. It's a common trend now for businesses to have control centers of some form. Maybe at sites, maybe remotely looking over multiple sites. Large quantities of information come into these centers and get used to drive operational decisions. Some of those decisions are for human operators, but increasingly they're making automated decisions under uncertainty, and they're getting used to coordinate and control fleets of equipment. All of this in a real world environment, all of this with uncertain data, uncertain outcomes. Uncertainty not just in the data, it's in the weather and the future world events that might impact commodity prices. That's sort of the backdrop to the direction the industry is taking. So we have to start somewhere. So one of the interesting areas to consider is how we represent the uncertainty in the information and the data we generate and use. As Hugh said before, all sensors have some degree of uncertainty associated with the measurement. Could be as simple as the physics of the device. All of these types of systems are at their core estimating a quantity of interest based on some inputs, and the inputs are in some way uncertain. But the industry norms at the moment for how we represent data typically don't maintain that in a probabilistic form. As an example, consider the geological representations in use today. Block model is probably the most standard. It's literally a block with parameters that represent the information within that area, averages almost. There's not an explicit uncertainty associated with that. A lot of the techniques used to develop the block model use uncertainty, but once it's built, it's not explicitly maintained. The experts, the individuals involved in building it, they understand what they're more or less certain about, but the information is not explicitly encoded in the default representations that flow into mainstream use. Now, to do that's a hard ask, but it's a real example at the moment of a key representation, key to the core business of mining, that doesn't represent uncertainty. Another common one to visualize would be survey systems, a representation of terrain. If I were to show a survey model of an area, and imagine sort of 2 points with a straight line in between them, how would you interpret that? Is it that the ground between those points is actually perfectly flat, maybe a concrete slab, or is it just that the 2 points are survey points and someone's drawn a line between them? In the latter case, which is quite common, the line is probably not a representation of the real surface, but without any further information encoded, you can't tell that. Next question is, does it really matter? Well, it depends on the application. What level of detail is sufficient really depends on what we're trying to use the information for and our ability to consume it. Having a spectacular, brilliant, probabilistic information representation may be great technically, but it needs to be understood by a wide range of roles in the field, and they might not all have PhDs. So just for a moment, consider some of the rich types of information we actually have. We've got equipment, we need to know where it is. And we need to know how to use it to maximize some objective under uncertainty. Some of it's mobile, some of it's fixed infrastructure, often it's in really harsh environments. We need to know the status, the health of the equipment. Is it likely to function effectively? When and how should it be maintained to maximize some objective, be it longevity, reduced downtime, aligning shutdown windows, or some complex combination of any of these and more. Then we've got the ore body itself. We need to understand what's in the ground, sometimes very deep underground. We can't just look at it. There's typically exercises where samples are taken from drill holes, but this takes time and can be expensive. And even then, it might be sparse data, certainly sparse relative to other applications where you can just go out and directly sense or look at something of interest. And then based on that and expert knowledge, you've got to form a model, a representation of what's underground. So we're interested in how much material is in the bucket of a loader or in a shovel or in a truck. And even if you can get a noisy measurement on the vehicle, it's going to shift, it's going to mix, it's going to blend as it passes through the value chain. We could start with a perfect estimate of material in the ground, but every time it gets moved, every time it gets loaded into a bucket or a truck or on a conveyor or a stockpile, there can be dilution, some form of mixing, and that's all going to increase the uncertainty along the business. But today, right now, we use all of this data and more. We deal with the uncertainty, and we make a range of operational and business decisions based on that. And fundamentally, it works. I guess the interesting question is what can be done better? If we can explicitly measure and maintain uncertainty in some of these processes, how much better can we do? So regardless of the human aspects, I guess as the industry adopts more automation capabilities, the need to understand and handle uncertainty differently also becomes more important. It's hidden in many cases, but it's actually very real. You notice it more and more these days. To pick up the example I used before of a survey or terrain model showing a line between 2 points, if you're going to use that for broad volume estimates or to show other people, it's probably okay. But it might be that autonomous systems coming in need to traverse that area, and maybe they need more detail to be able to do it. People tend to handle that ambiguity pretty well. They'll look at the ground and they'll pick their own path. But some of the automation systems around there, they just do what you tell them. If you tell them it's perfectly flat, they will behave accordingly. So it might be necessary to introduce richer representations in those sorts of cases. Certainly within the automated equipment, probabilistic representations are being introduced. An obvious and simple example is localization filters in automated trucks, drills, etc. They're fusing information from LiDARs, radars, GPS, inertial systems, building world models, detecting people, all of it using new, I guess, use not quite the right word, but introducing new probabilistic techniques into the business. But the detail is largely hidden from day-to-day users. Many people, maybe most people, they don't dive under the hood of how the automation systems work. But the introduction of these is actually having a big impact as people start to get a deeper understanding of it. Well, all of the challenge of estimating quantities of interest based on uncertain data can be a research challenge. And the ability to support decision-making under uncertainty is a research challenge. Consider now that any one of these new capabilities would need to operate at the scale that we operate for it to be useful. And I mean large geographic scale in terms of volume of data, and also complexity. And as automation technologies are adopted, it's also important to consider temporal scale, handling probabilistic information such that it can suit both real-time autonomous systems, as well as potentially slightly more relaxed timeframes for human decision support. The concept of one version of the truth is common within the industry. It refers to having a single trusted data source that all users can work from. If we're developing new representations that handle uncertainty, we need to make sure we don't end up with the Wild West, with a proliferation of them, of having too many different new representations. Now, at a technical level, there's sometimes answers like cloud or edge processing will solve all the large data problems. Big databases, cloud compute, I mean, they can indeed be part of the solution, but they may not be the whole solution. And whatever techniques are used to manage uncertainty at that level, they will need to integrate in some way with what we call operational technologies. So that's the typical real-time systems that operate at the site. Autonomous vehicles, path planning systems to coordinate fleets of vehicles, and there can be hundreds on a mine site. Imagine coordinating all of those. There's different types of vehicles, different capabilities, all doing different tasks. They move differently. Some can overtake, some can't. Some engage the ground and might need a representation of the geological structure to do their job, and some just move material. And then you need all the infrastructure to move this around. It has to exist, not only at the mine site, but likely to the outside world. Mines in remote areas are not always connected to the world with all the bandwidth that everyone wants. So again, there's another area of difficulty in terms of making these things fly. So the data systems that operate at an enterprise level, I mean, ideally they should integrate with the operational technologies if we're going to maintain our concept of one version of the truth. And the operational systems, they may well be geographically distributed with imperfect comms. So any of the algorithmic capabilities, any of the new research, fusing information, representation, providing decision support, they should all be part of the same distributed information network. Other industries like defense, etc., have looked at things like decentralized data fusion and decentralized control in various guises. Have we looked at those sorts of technologies to bring them into our industry to actually distribute the information accordingly? So as we start to embrace more of the data analytics information management systems and operate them at scale, we do need to look around at other domains as a starting point and start to bring more of those into the mining area. I guess I've talked quite a bit so far about the mine, the sorts of data we typically get and the representations and how much of that is uncertain, about how the introduction of automation has started to get some of the probabilistic techniques into the mine, but that's just the start of the mining process. It's the start of a little bit of the business. A processing plant, for example, also generates large amounts of data, also used for control. And within the industry, I mean, that's often wrapped up under the term process control and analytics, PCNA. Now take an even bigger picture view again and think at the scale of an entire mining value chain, from exploration to mining to a processing plant, and then even to market afterwards. That introduces even more complexity, more data, and more uncertainty. But automating things at that level is really one of the key interesting challenges around at the moment. And then there's so many different layers of control loops: real-time control of the vehicle, real-time control of a fleet of vehicles, their trajectories, real-time control of all of those vehicles, the tasks they're undertaking and any interactions, mine plans, shift plan, daily, weekly, monthly plans, processing requirements for different types of ore, all of it coming through. And then trending and identification over the top of that all the time. It's complex. And it's not any one of those, it's all of them, all the time, in real time, simultaneously. That's sort of the research challenge I'd start to throw out there. To bring automation back into this, step one is really just looking at the vehicle piece. And that's what our industry has really done for the last couple of decades. Now they commercially exist. You can get trucks, drills, loaders, and it's good. They add value. But the broader picture, the broader operation is still pretty much similar. We've automated only a section of our value chain, vehicle by vehicle. So one of the key messages I'd want to leave everyone with today, and the direction we're going, is to look at data, analytics, uncertainty management, but look at it to automate something at the level of a whole business, not just vehicles. It has to include all of the information systems that underpin it, and the uncertainty has to be managed effectively. So if we're going to start thinking about automation of the operation, that means mixed fleets, different mining methods. As an industry, though, we're still very early on in that journey. We need to look beyond the vehicles. For better or for worse, it's historically been a very metal, hardware-centric industry, and it's starting to move beyond that. We need to look under the hood of some of the new capabilities now, how they're built, not just how many tons it can carry. Simple example, you can look at an autonomous and human-driven vehicles, or even two different automated vehicles, and you can easily tell the physical differences. But what about the core functions underneath? How they handle uncertainty, localization accuracy, again, a simple one. Which one is more or less certain? What format's the information in? Will it integrate with other systems? Is the algorithm used in that part of the system even mathematically compatible with how I want to use it downstream in a processing plant? So how should I look at a new representation of an ore body that explicitly includes things like uncertainty and flow that through the mining process, from ground to trucks, over conveyors, all the way through to the plant? And what would we do if we had this crystal clear, perfect knowledge of anything and everything at all time horizons, if there was no uncertainty? In theory, we could optimize and control our actions knowing we were taking the best decision. But we don't. There is uncertainty. So we need to be able to understand it better, to be able to use it to effectively control the systems in the business. Let me just finish by bringing these a few of these threads together. I guess we're already seeing a lot of the new automation technologies reach levels where we can start operating them competitively. But we need to keep moving forward with a view to bringing in, I guess, a wider variety of mixed fleets with more mining domain knowledge, rather than just moving vehicles from A to B. We need to extend the scope. We need to integrate technologies end to end. We need integrate as a keyword to actually focus on. And all of that's going to be underpinned by new fundamental research in how we can represent, fuse, and use the information, uncertain data in an effective way. We need to be thinking about the algorithms and how they're going to interact as information along the value chain is used. The other catch is all of this has to be usable in the field. It has to be understood at some level by the operational staff. They need to trust it. They need to be able to support it at scale. There's a whole bunch of different standards out there and formats in use today that don't handle uncertainty, and to be honest, they're not going to disappear. So whatever new techniques we look at from a research perspective need to be able to integrate and operate with legacy systems, with existing hardware, software, and processes. There also needs to be a commercialization route, a support organization, someone we can call at 3 in the morning when something doesn't work if there's a real problem. So almost out of time, I guess. So let me close with a final thought that I think there's actually an exciting opportunity in this domain for us to undertake brand new and fundamental research in new capabilities for estimation, control, and prediction under uncertainty at these sorts of scales. And getting it right providing the solutions to actually genuinely be rolled out into a business, that can add a lot of value. So let me pause there.